Hello and welcome back to What the Fuck is SRE. We're about halfway there and it's time for an exciting keynote. So thank you so much for continuing to be active participants, bring your questions, tweeting out at hashtag WTF is capital SRE, and just being enthusiastic and sharing the learning. Next up, we have someone who I know really takes diversity in hiring seriously, which makes for better code and teams. Someone who brings the whimsy back to the O'Reilly book covers with unicorns and has really made y'all consider if you're ready to test in prod. I think she'll say you are. So without further ado, we have Charity Majors coming on the stage to bring a promise of helping you deliver the promise of continuous delivery. Thank you, Charity.
Thank you so much, Jennifer. I would argue that it's not a question of whether you're testing in production or not, because everybody tests in production. The only question is, do you admit it or not? And if you admit it, it makes you more likely to do a good job for your customers. That said, I want to be talking about the promise of continuous delivery. That was an excellent intro, so I won't rehash anything here, except to point out that the observability engineering book with the cute little maned wolf on the cover has gone into print, and it will be out in book form in less than 2 weeks, I think. So 3.5 years in the making. All right. So I'm gonna print a quote here. How many of you have ever thought or heard something like this? I'll do whatever it takes, right? Even if, I come from ops, right? We're notorious for our our masochism. That's just the job, I'll throw myself on the grenade. I'll do whatever it takes, right? Or maybe as you get more into management, you might hear or think things more like this. Like you have to sacrifice the health and sanity and happiness in your, like, this is what fuels great products, right? Sacrifice. I don't think so. I have never actually seen, over the long term, I've never seen the happiness of your engineering team and the happiness of your users significantly diverge. I've never seen a team of absolutely miserable engineers creating a product that delights their users. And I've never seen, a company with absolutely miserable users where their engineers enjoyed their work, right? There can be some tension, there can be some optimization in the trade-offs day to day, et cetera. But over the long run, they tend to reinforce each other. They tend to rise and fall in tandem. Similarly, it's way more fun to be a great engineer than a mediocre one. It's way more fun to do a great job than a crappy job. It's more fun to make users happy than to let them down. And it's more fun to be, creative and curious than it is to just grind it out. What all of these things have in common is that, it's not just, navel gazing to think about being a high performing team. This is actually something that we should all want to work on a high performing team. And I know it's like so much easier said than done, right? And a big part of it is giving yourselves the tools and the telemetry to truly succeed. You in this day and age, you do need to have a substantial budget for paying for top class tools. And you can't really hope to be a high-performing team without it. And the point that I'm getting for here is you can't actually hire your way out of this problem. You can't build a high-performing team by just hiring more people and more people. In fact, if you have a low or mediocre performing team and you add more people to it, you're much more likely to make it worse. You're much more likely to just add a lot of contention and waiting around a system that's already slow and clogged. It's way better to focus your energy on becoming a high performing team and then focusing on recruiting or hiring. So I've said a lot about how great it is to be high performing. I don't think anyone here is going to disagree or argue with that. But how well does your team perform? Let's start there. for the first point I want to make is that this is not the same question as how good are you at engineering. It is only loosely related, if at all, to how good you are. It's somewhat related, but it's not. It's a very different question, and it doesn't just. It's not additive, right? You don't just add great engineer, great engineer, great engineer, great engineer equals great team. Like, does not work that way. High-performing teams are ones that get to spend most of their time solving interesting new problems that move the business materially forward. We should all want to be in high-performing teams, and the business leadership should be highly invested in making sure that teams are high-performing. Lower-performing teams spend their time doing everything else. It's really, I talk a lot about shipping quickly, and sometimes people are like, isn't that going to burn your engineers out? And I'm like, no engineer ever got burned out from shipping too much. We get burned out from shipping too little relative to our effort, right? How high performing your team is, the best measures I know of for this are, of course, the DORA metrics. How often do you deploy? How long does it take? How many times does it fail? How long does it take you to recover? I would, of course, add a fifth, which is, it's not just how often you alerted, but more importantly, how often are you alerted outside of working hours? Because those are the alerts that really correlate tightly to it's an emergency, it's on fire, and it's going to burn your engineers out really quickly. We can handle a lot of alerts during the day if they're of a certain type and handle whatever, but out of hours, like, you should only be paging people for critical stuff, and you should be tracking how much does that happen. There's a really big gap between the elite teams and the bottom literal half, right? It's a difference between like deploying on demand whenever you need to, many times a day, versus once a week to once a month. That's a really big gap. And again, I want to stress that this is not a question of the best engineers versus the rest of us. And I need to add the most recent stats to this graph, but they actually accelerate this trend where, more and more teams are figuring out how to become elite performers, but everyone else is actually losing ground. And this makes a lot of sense if you think about it, because the longer a team exists, the more commitments it tends to accumulate, the more contracts it tends to accumulate, the more entropy takes hold, the bigger your data set gets, the more your user queries and like requests change. Like, you're constantly you have to, in order to be a high performing team, you have to nail the art of doing less with more constantly staying up on what are the good tools. Have tools gotten better? How can I leverage the same amount of effort to do even more than I was this time last year? Constantly. But the good news is, like, if you can get into that rhythm and you can figure this out, it really pays off. If you're on a high-performing team, you're learning good defaults, good instincts, good best practices, standard ways of doing things. These are things that always seem obvious once you're doing them, so we tend to underestimate just how much effort went into discovering them and developing them and like curating them and growing them locally. These are not taught in schools. They're an orally transmitted tradition in our profession. And just look at the sheer amount of human misery that's like contained in this gulf between, median performing teams and high performing teams. 2,600 times faster to recover from incidents. Oh my God. Right? Look how much faster these people are learning. Look how much less time they're spending on bullshit. So how do we make these high performing teams? You ask a lot of people, they'll be like, well, hire only the best people. Line up outside of MIT and Stanford and outside of Google and Facebook and whatever, right? And setting aside the question of whether you even can evaluate the best engineers, it doesn't actually matter as much as you might think, because the team is what delivers, not the individual. The smallest unit of software delivery and ownership is a team, not a person. You have a problem if the smallest unit of software delivery is a person. That's a problem. That's a bus factor problem, right? So, if given the choice between hiring a great engineer who's a mediocre teammate and a good engineer who's a great teammate, I would always choose the good engineer who's a great teammate, who's a good communicator, who is humble and curious, over somebody who has more skill at data structures and algorithms. Hiring the team is also just the beginning. Like, good managers don't, quote unquote, hire people. They build teams. They grow teams. They don't expect the experts to just show up at their doorstep fully formed, right? They expect you to develop their talent, and they invest a lot of effort into doing so. A leader's job in tech, if it is anything, it is to bring on the right people and then craft the right feedback loops. It's not that great engineers make great teams, not to belabore this point, but I will say it one more time because it's actually exactly the reverse. Great teams are what forge great engineers. Working on a great team is the surest way to make you a great engineer because your learning just accelerates so much. You get to learn, you get to piggyback off of all of the learnings of, the generations of engineers that have come before us. We can illustrate this by just looking at, the person on the right joins a high-performing team, deploys thousands of time per year, spends little time firefighting, and the one on the right who joined a, mediocre performing team and deploys 5 times per year. Who do you think is going to be a better engineer 2 years from now? And what happens when an engineer from the elite team joins a team, mediocre? A lot of our hiring philosophy is premised on the idea that if you hire the best engineer, they'll drag the entire team up. But if it takes you 2 days to ship a single line of code and you hire the best engineer in the world, it's still going to take them 2 days to ship that line of code, right? If it takes you 20 minutes to ship a line of code and you hire, a good engineer, they're all going to ship in 20 minutes. This is why systems are so important. Your ability to ship code has, you need to have a working knowledge, of course, of algorithms and data structures, but your ability to ship code is primarily a function of the socio-technical system that you exist in and participate in, which is why it's so important for technical leaders to focus on the feedback loops that are at the heart of this system. There's actually in sociology, there's an abbreviation called the FAE, the fundamental attribution error. That means that we tend to attribute so much of our success or failure to ourselves instead of the system around us, when, it's like the system is invisible to us, but the system is really what matters the most. Create the right system and people will excel. Which brings us to CICD. Speaking of feedback loops, fear around deploys is the single largest source of technical debt in most organizations. And everybody does CICD these days, right? Anybody you ask, do you do CICD? We all go to conference talks about this. Everybody's going to say yes, right? And I love this quote from this is from our friends at Instagram, where one of their company values is that shipping is the heartbeat of your company. And I love that. Shipping new code should be as everyday, as commonplace, as ordinary, as unremarkable as a heartbeat, as regular, as it should be a nothing burger. And CICD is how we get there, right? So, do you do CICD? And a lot of people will say, yes, of course we do CICD. But then you start digging into it, and it's like, well, we run tests, sure. We have an artifact. They're doing continuous integration, sure, but the entire point of doing CI is to unlock the ability to do CD. And I'm not talking about continuous, quote unquote, delivery. Continuous deployment is what will change your life. It's not continuous delivery. Once you merge your code, when you've made your changes, you've gotten them reviewed, you've run your tests, you merge your code domain, and should automatically get, tests should run, create an artifact, and deploy to production with no manual gates in 15 minutes or less. If you take no action, it should go live. I understand why for years and years they were like, no, you just continuous delivery. It means you're ready to ship at any time, right? You've done all the things so you can ship at any point in time. Well, this was in what, 2010 that we started talking about this stuff, and I get why that was as good as we could do then, right? We didn't have observability, we didn't have chaos engineering, we didn't have progressive deployment. Most of us, we didn't have a lot of the tools that have been developed just in the past 5 years for every company to buy their tool and just and have this. You can compose this great tool chain that previously only places like Google and Facebook had available to you. We have better tools now, and it's time to stop hedging. If there's anything that we've learned from being in computers, it's that nothing is you don't know until you do it, right? Saying you're ready to do it is not the same as doing it. You don't know until your code runs in production. And honestly, if you aren't going to hook up your CI to production, why even bother? Just run it on your laptop. It's the same goddamn deal. I'll go so far as to say that any CI/CD job that ends without having deployed your code to production was a failed run. This is the beating heart of your company. This is the core feedback loop of software delivery. It's the 808 drum that underpins everything that we do, right? The speed and cadence of your CI/CD pipeline will basically determine how high performing your teams can be more than any other variable. Excuse me. So we're talking about feedback loops a lot here. So, right, what does a good feedback loop actually look like? Well, it looks like this. Engineer merges a change. It's been code reviewed, of course. They've run their tests. With any user visible changes hidden behind feature flags. Hiding the changes behind feature flags is what decouples deploys from releases. It makes it so that you can deploy continuously, but you can schedule your releases. You can put the marketing team in charge of releases, and users will only click on your changes and use them when you want them to. This triggers CI to run tests, build an artifact, which is then deployed or canaried to production or some form thereof. At Honeycomb, we don't drop them straight into production. What we do is we have the production cluster that runs the combined workloads of all 350 customers of Honeycomb. So, and then that code is instrumented, and that instrumentation goes to the dog food cluster. And dog food is instrumented, and that instrumentation goes to the kibble cluster. So when we have our artifact, it automatically deploys to kibble. And there's real traffic there, right? People are using it all day long. And then it's been running there for an hour or so. We check a lot of metrics automatically. And if the metrics look fine, if people are using it, then it automatically gets promoted an hour later to the dog food environment. And, that has a lot of real traffic, like a ton. And we capture metrics from it, et cetera. And if it all looks good, after an hour, it gets promoted again to production. So it's not like we drop it straight into production, but it automatically goes to production with no human gates. That's the important part. And importantly, I think that this feedback loop needs to be tight. It needs to be in a place, a place that's running real production code, has real users within 15 minutes or less. This is a tight enough time loop so that you can expect your engineers to go and look at it and look at the output of their instrumentation and ask themselves, is it doing what I expected? Does anything else look weird? Notice that only one change set by one engineer per build, no manual gates, no manual QA. In fact, you want it to be a predictable amount of time. It's almost as important that it be a predictable amount of time as it is that it be a short amount of time. And of course, feature flags. As the Mandalorian would say, this is the way. The reason this matters so much is because that precious interval of time between when you wrote the code and when you deploy the code is everything, right? Keeping this small is it's the difference between toil and happiness as a developer. It's the difference between nimbleness and bloat. Keeping this short is more important than people realize. And I know that we've been talking about fast deploys for like a fucking decade now, and 2 decades, right? I think it matters even more than you think it matters. Because at the moment when you've just finished writing your code, right? You've gotten it reviewed. You have your brain cache has everything. It knows what you were trying to do, why you're trying to do it, what the intention is, the things that you tried that didn't work, what the variables were named, and this lasts for how long? Not long, until you move on to your next problem, and then it starts to decay in your head. And this is why engineers can find upwards of 80% of all bugs in that interval, just as long as they have actual observability, right? They instrument their code, and then they close the loop by going and looking at it and asking yourself, is it doing what I wanted it to do? Does anything else look weird? Right? Like, so at Honeycomb, when we were shipping a change for like the compaction of our storage engine, the first pass, we just shipped a bunch of instrumentation so we could observe it, right? The second pass, we started adding like parallel changes so that we could see like how many bytes were getting compressed, what the size before was, what the size after was, the compression factor, which, so we could like start asking questions like which users are going to be most impacted. Will it be larger? Will it be smaller? You have to close the loop by looking at it, or else you're just guaranteeing that the person who will find the problems in your code will be somebody days, weeks, or months from now, and they'll have to start fresh from scratch. They're not going to have all that context in their head that you have in your head right now. And having it be a predictable interval lets you hook into the body's own like intrinsic reward systems. You get muscle memory that tells you, I'm not done until I've looked at it in production. Dopamine hits. That's what we live for. I fixed it. I found it before our customers did. That's amazing. A short interval also lets you hold the line against batch deploy so that you're deploying by one engineer's change at a time. This is the part of the feedback loop that leads for software ownership, right? If you know that your changes are going to be live within 10 or 15 minutes, you're very likely to go look at them, right? You want to see, is it working okay? And conversely, if you merge your change domain and you're pretty sure that at some point in the next day or two, your changes are going to go out along with anywhere from 1 to 100 other developers' changes, you're never going to look at it. You're never going to feel like you own that deploy. You're never going to feel like it's yours to own and be responsible for. If the interval starts to grow, things start to get grim. If your interval is on the order of like hours or days, you're almost certainly batching together lots of people's changes. You're not deploying automatically. And this is what I start to think of as like the software development death spiral, where it takes longer and longer. So this leads to larger diffs, longer code reviews, more time for everyone spent paging state in and out of your brains. Changes getting batched up and deployed together, which severs the ownership, which means that anytime a deploy fails, it's like, okay, 25 engineers diffs were in this build, so it failed. So now 25 engineers, the rest of their afternoon is blown while we try and figure it out. More and more engineering cycles get spent waiting on each other, which means that we soon need specialist teams like SREs and build engineers and product managers and project managers and more people teams, which means more coordination costs, all of which costs more time. You can spend your life like chasing all those pathologies that result from having a long build time, large diffs, long turnaround time, the code review problems, or you can fix it at the fucking source. 15 minutes or bust. Now, it isn't just about the economic arguments, although I think it's really important for us to talk about these economic arguments because they're the arguments that will convince the business teams. The question of how your team performs, which, again, high-performing teams get to spend most of their time doing cool shit, and low-performing teams don't. This is a quality of life issue, right? Software engineering has the potential to be a creative, exciting, fulfilling career, not 12 hours a day of like toil and bullshit. So, this is a quality of life issue, which means that it's also an ethical issue, in my opinion. I think it's really important for us as engineering leaders to invest our energy into building teams that are low in toil and high in the things that make work worth doing, right? Autonomy, mastery, and meaning. And this means keeping your intervals low and feedback loops tight. How much is your fear of continuous deployment costing you? Remember I said that fear of deploys is the biggest source of technical debt in most organizations. Well, I have a rule of thumb, which is that if it takes X number of engineers to build, maintain, and run your systems with a 15-minute or less delivery interval, if it takes you hours to ship, it's going to take you twice as many people. If it takes you days to ship, it's going to take you twice as many more. If it takes you weeks to ship, double it again. And if anything, I am underestimating. If anything, I'm being conservative here because the data shows that it's actually an exponential growth curve. The cost of finding and fixing bugs or problems or even understanding your software, it goes up exponentially from the moment that the bug is written. And if you've ever wished you could have twice as many engineering cycles, God, what would you do with so many resources, right? If you had twice as many engineering hours to build shit. What could you build? What could you solve? Fix your fucking build pipeline and let's find out. One last point. I was tweeting about this a long time ago, and somebody responded and said this. She talks to CTOs a lot. She said that from speaking with them, they don't believe that true CICD saves resources. They think that 15-minute deploys are a law of diminishing returns, and they think that the risk of shipping something from the business that they don't like is greater than the risk of shipping code. I hope not. And I just gave this talk last week, by the way, at a CTO conference, which is why I dragged up this slide, because it's an embarrassment if true. If your engineering leadership has one job, surely it's to ensure that every engineer gets to spend as much of their time on high value work as possible. The data is clear. Like, go read Accelerate. It's been out for years now. Go read the DORA reports. Go talk to your team members. Engineers who have worked on teams with a short delivery cycle are unwilling to ever work anywhere else again. So, are we too busy to improve? I hope not. All right. The end. Yes, questions.
Well, it's interesting because what you've created is much more of a really active debate in the chat. So you should definitely check that out afterwards, Charity.
Yes.
But definitely a question that I would extrapolate from that debate is, are any of the current DORA metrics high performing, excellent teams in a well-regulated industry like banking or defense?
Yes.
Or
yes.
So
Even
it doesn't matter any industry.
If your quality needs are sky high, then you better fucking be able to trust your tests. You better be continuously improving them. But you'll note that I didn't say just deliver every change to users like flat out, right? The thing is this. Deploys are about increasing the confidence in your code. There's only so much confidence that you can build before deployment. There's a lot more confidence you can build after deployment to real users, right? And that doesn't have to be to everyone, like to 100% of all customers. You can have, internal groups that you're testing with. You could have like groups of, these are our risky, users that we can deploy to first, whatever. The point is that, you reach rapidly diminishing returns when you're trying to do stuff in a false environment. The point is to get it into a realistic, an environment where it's being used, if not by your actual most important customers, by customers that are as similar to them as possible. Because most things that you need to build confidence against, you're not going to see until they're in that environment. And so if all you do is build confidence before the deploy point, you're going to inflict most of the bugs on your actual users that you care the most about.
So when you said at the beginning, it's not that if you test in prod, it's if you admit you're testing in prod. It's just, are you experimenting on your users and pissing them off? Or
well, it's just, are you doing it well?
Right.
Like, if you say you don't test in production, but that tells me is that you're not investing in the tooling to do it wisely. Right? There are lots of ways to do it wisely. There are ways, we have so many fine-grained tools now that'll let you, choose, slice and dice whether it's with observability, if you have the access to raw rows, you can slice and dice and compare exactly how is this user's experience different from that user's experience. Whether it's routing, whether it's, teeing your traffic, whether it's, you could tee it to a jail where your users never even see the response. You can do all sorts of creative, interesting things in production. Your users never have to see the results, but the developer needs to have the ability to see what's actually happening, or you're just blinding yourself. You're just not giving yourself access to actual tools that will help you solve your problems.
you're in denial and you're not really learning about your users either and how your systems work either. A question from the audience is it time to remove the merge request pull review from the CICD process?
By that, you mean don't review your code? That sounds bad. No, you absolutely make time for code review. But the point is, by the time you're ready to merge your code domain, it should be ready to be shipped to at least the first stage of your post deploy hardening process.
And how do you keep up with all the awesome tools is another question.
So this is where I think that we've had a bit of a failure of leadership when it comes from engineering managers and directors over the past few years. I think that we really need to get better at translating the needs of engineering teams to stay current and stay up on things in order to, like you saw that graph where most teams are their ability to ship is declining over time. In order to achieve escape velocity, right? You need to be dedicating actual engineering cycles to improving, trying out new tool sets, evaluating new ones, seeing what actually work for you. Call it like a 10 or 15%. It's not tech debt, it's an investment. It's the kind of investment of your time that's like investing in going to college so that everything that you do will have higher impacts, down the line. Have you ever seen those teams that have have you ever seen a product and they're like, oh, that's a cool app? And you look into their company and it's like, they have 800 developers? What the hell are they all doing? These are teams that are not investing in their internal. I guarantee they have a long cycle to ship. They don't have a golden path for their tooling. They're not keeping up on things. They're just they have money to hire engineers, so they hire more and more engineers, but you can't hire your way out of this problem. You have to pay attention to those feedback loops and optimize them, and using new tools is a great way to do that. It's not free. It does take dedicated engineering upkeep, but it's the best investment of your time that you can probably make.
Because otherwise in those Uber organizations you're maintaining, you're not providing any creativity, you're going to have burnout and retention issues.
You, as an engineering team, you want to accumulate as few commitments as possible. And ideally, the code that you commit to owning and understanding and maintaining is the stuff for your users, not for the engineers who are building for the users, right? Those are not contracts that you want to accumulate. You want to make that some other company's problem. I think of it as vendor engineering. I think that vendor engineering is one of the most underrated and challenging skill sets and a real growth opportunity over the next decade or two.
Vendor engineering, and that's different from a sales engineer, right?
Vendor engineering meaning you're not on the vendor side, you're on the company side. And so we see a lot of observability teams within companies, and these are not companies who are building their own observability software, because that would be dumb, but they are there to constantly evaluate the vendors that are on the scene, to make choices, to build libraries for internal use, to build to educate their engineers internally, to derive patterns, build common dashboards, whatever. They're there to make the panoply of observability software that they buy easily consumable by the dozens of other engineering teams in the company. And that's a real skill set that is challenging and immensely impactful.
That sounds like a super fun job as well that people would like to do. It sounds like to old-fashioned management, it sounds like just people playing around with stuff and getting swag.
Exactly.
So is part of the problem that, do you need leadership to have that much technical know-how then?
No.
Or should they not be making the decisions?
We need our engineering leaders to get better at translating our needs into their language, talking to them, not just if you go to a CEO or something and you're like, well, our engineering velocity, blah, 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 blah. So we need to spend 30% of our time doing blah, 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 blah. They're just going to hear, well, that's 30% of the time that you're not delivering value for users, right? We need to start explaining this to them in terms of dollars and time, right? And when this comes down to, this is an unassailable argument, because how much does an engineer cost? Minimum $200K a year, maybe more like $500,000 a year. These are, and yet it's so much easier for most managers to get headcount than it is to spend money on a tool. This is completely backwards. So I really think that as engineering leaders, We really have to get better at communicating to the business why it matters in terms that they can understand. We can't expect them to speak our language. We have to translate it for them.
And we're not trying to take your jobs away with tools. We're trying to make you actually enjoy your job as a creative knowledge worker.
Exactly.
Thank you so much, Charity. We could go on and on and on, but our viewers deserve a break. Please do join the chat if you haven't yet and hop in, because it is popping.
Awesome.
That talk was on fire. Thank you so much, Charity. And thank you, everybody that's having this, that we're invigorated by Charity in this debate. You have a break. Take that time to network. Take that time to visit our amazing sponsor booths. And I'll check back with you soon. Thank you.